Introduction to Factors and Multiples. A prime number is a number which has only one and itself as factors. A composite number is one which has other numbers other than one and itself as factors. So let's write P for prime and C for composite. 15. It has 1 and 15. It also ends in 5, which means 5 is a factor, which means it is a composite number. 31, please check the divisibility table does not go in 2 because it's ending with 1, which is not an even digit or 0. It doesn't go in the 5 times table, neither does it go 3 plus 1, which is 4, does not come in the 3 times table or 9 times table. And if you check, you will see that it is a prime number. 46, it's an even number and ends in 6, so it is a composite number because it has got 2 definitely as one of the factors. Let's look at 97. 97, when you try out various combinations along with 9 plus 7, which is 16, does not come in the 9 times table or does not go in the 3 times table, is not ending with 2, 4, 6, 8 or 0, does not go in the 2 times table. When you check this, you will find that this is the largest 2-digit prime number. Similarly, 101, again, when you check, you will find that it does not go in 2 times table, 3 times table, does not go in multiple number of tables. For example, let's check whether does it go in 9 times table. No, 1 plus 1 is again. Remember, you have to also test the divisibility for the 11 times table. And we see that 101 does not go in the 11 times table too. And this is a prime number. How do we test divisibility by 11? You will look at the alternate digits and add it up. For example, 1 plus 1 becomes 2. 2 minus whatever is left in the other digits. For example, if it's a 4-digit number, you would have added 0 with that other digit and found out the difference between the two. If that is 11 or if it is any number divisible by 11, then you will have the entire number divisible by 11. 143, if you see, you will actually find that it does not go in 2, 3, because when you add it up, it does not go in the 3 times table because 4 plus 3 is 7 plus 1 is 8. You will actually be surprised. You may think that it is a prime number, but if you see, it does go in 13 times table. So here, this will be a composite number. So you will have to make sure that you're clear that it does not go in any other table other than 1 and itself. Let's look at the next one. So we have the prime factorization for the following numbers which we need to do for 84. Remember, prime factorization is where you have to write. Let me show you one example and the other ones we can start doing it on our own. 84 is written as 2 multiplied by 42. Now 2 is a prime factor, we know, so we can stop there. 42 is split and written as 2 multiplied by 21. Again, 2 is a prime factor, so 21 can be split and written as 3 multiplied by 7. So you know that the prime factors are 2 into 2 into 3 into 7. So you write it out here. 2 into 2. Remember, you're taking the prime factors here. Into 3 into 7. Similarly, for 102, if you actually split it and see, you will find that it goes in 2 times table. So I'm going to directly do it. You can do it by the prime factor tree method or a method that's comfortable for you. It is 2 multiplied by 51. And you know 51, 5 plus 1 is 6, which goes in 3 times table. So it is 3 multiplied by 70. Please try it out by any other method and verify whether you've got this answer. For all these questions, you need to see the divisibility test and start trying it out. For 145, you know that it ends in 5. So you know that it is 5 multiplied by. Now when I say 5 multiplied by, I know 5 is a prime factor. So I can definitely write 5 multiplied by. You will see that when you divide 145 divided by 5, it will be 29. And 29 also happens to be a prime number. So you can write 5 multiplied by 29. 96. 96, when you see, it is ending in 6, which means it is 2 multiplied by. Remember, when it is 2 multiplied by, it gives you 48. So keep 48 in mind here. Just circle and keep it for your reference. So 48 is nothing but again 2 multiplied by, it becomes 24. 24 is nothing but 2 multiplied by 12. 12 is nothing but 2 multiplied by 6, and 6 is nothing but 2 multiplied by 3. So it is 2 multiplied by 2 multiplied by 2 multiplied by 2. So you have 1, 2, 3, 4, 5. So check whether you have 1, 2, 3, 4, 5 of the 2's here multiplied by 3. And the next one, 135. We know that it does go in 5 times table because the last digit is ending in 5. So 5 multiplied by, so we'll have 135 divided by 5 will give you 2 and 7, which is 27. And 27 can be split and written as, you will have this is 27. Please remember that. 27 is nothing but it is 3 multiplied by 9. And when you say 3 multiplied by 9, you have 3, which is a factor here, which is a prime factor. 9 is again split and written as 3 multiplied by 3. Because 9 is a composite number, so we need prime factors. So we'll have 3 times and then multiplied by 5. The next one is where we are going to talk about the pairs of numbers which are given, and you'll have to find out the HCF. HCF is the highest common factor. That is, what is the factor which is between the two which is common and which one of them is the highest. For example, 14 and 21. You can do this by multiple methods. Let me show you one here and the others I can do it. And you can just check that. 14 and 21. Remember, you're looking at these come in 7 times table. So 7 2s are 14 and 7 3s are. Is there anything else in common? No. So we stop here and this becomes your HCF, which is 7. So similarly, if you check for 24 and 36, you will see that it comes in the 6 times table, but at the same time, multiple of 6 times table would be 12 times table. So the highest common one would be 12, which is here. You'll have the 84 and 70, and when you check that, you see that 70 goes in 7 times. You also find out that 84 goes in 7 times table. When you get a common factor, try and see whether the multiple of that particular common factor also is a factor of this. And if it is so, then that becomes the HCF. So 7 multiplied by 2, since 7 was the common factor, we have 14. We see that yes, 14 goes in 84. Can you check how many times 14 goes in 84? Do you want to make a quick check here? 14. Remember, 84, it ends in 4. So let's try out, for example, 6's are. 6 4s are 24. Carry forward 2 and it becomes 84. And we know that 14 5s are 70. So which means that 14 is the HCF. Similarly, we have 49 and 64. And if you see, 49 goes in 49 and 7 times, whereas none of those go in 64 table, which means the highest common factor for these two is 1. So that's trick 1. So we have 39 and 63. If you see, both these numbers go in 3. Because when you add it up, this gives you 12. When you add it up, this gives you 9. Both goes in 3 times table. Multiple of 3 would be 6. Does it go? No, it does not go in 6 times table. And neither do we have 6 as an option here. So the HCF is 3. 28 and 46. If we see that both these are even numbers, so they will be divisible by 2. So we see that there is one more number which is 2 here, which matches to the HCF. Good. Let's look at the next one. The next set of questions here are problems. Let's look at the first one. Kia sells soaps in sets of 8 and shampoos in sets of 12. She sold the same number of both the items. So we need to find out what is the least number of each item she sold. So if she sold 8, so she would have sold 8 of those soaps. The next packet she would have sold, remember she's selling in sets of 8. The next would be 16. The next would be 24. The next would be 32. So let's pause here and see what about our shampoos. So we see that she sold 12 of those shampoos in each set. And she has the next one which is 24, the next one which is 36, the next one which is 48. So we are looking at the least number and we see that yes, 24 is the least number which of each item that she would have sold. Mrs. Sheikh has baked 150 cookies and 120 cupcakes for her office party. She wants to divide them into plates with each plate having both cookies and cupcake. So what is the maximum number of plates that she can make? So she has to make 15 and 120. So we'll have 150 and we have 120 as the total. So when we look at the common, which is there in both, we see that it goes in 3 times table. So it is 53s are 150, 43s are 120. Which again, we see once again, it goes in, let's say, the 5 times table. Remember, we're taking the prime factors here. So 5 tens are 50 and we have 5 eights are 40. And again, between the two, we have 2 times which goes in common here. So we have 5's r and we have 4's r. So there's nothing else in common here. So we pause. And here when we multiply, 3 multiplied by 5 is 15, multiplied by 2 is, she can make a maximum of 30 plates. So this is 3 and this is 0 written beside it. Great. So now let's look at the next one. The next one is true or false for the sentences given here. Prime numbers are numbers with more than 2 factors. So we just discussed that prime numbers have only 2 factors. So this is a false statement. I'm going to write F for a false statement. The next one. The pair of numbers which HCF equal to 1 is called co-prime numbers. Yes, that's a special name that we give when the HCF is equal to 1. So in case you didn't know, please make sure that you understand what co-prime numbers are. Co-prime numbers are those numbers where they have the HCF which is equal to 1. Remember in the earlier example of match the following, we did have the HCF for 2 of those numbers which is 1. So they are co-prime numbers. Product of two numbers is equal to the sum of the HCF and LCM. So we are looking at the product of two numbers is equal to, is it the sum? No, it is not the sum and hence this is false. Which numbers are divisible by 6 but not by 8? Remember, when you have divisibility by 6, what do? You have to check whether they are divisible by 2 and 3. How do we check divisibility by 2? It has to end in an even number which is 0, 2, 4, 6, 8. Divisibility by 3, you have to add up all the digits and find out if it comes in the 3 times table. And for 8, what do? We look at the last 3 digits and we see whether it comes in the 8 times table. So if you make a quick check, I'm going to give you an indication that you find that A seems to be divisible by 2 and maybe divisible by 3 too. But if you look at 8 and not by 8, I have to look at the last 3 digits. So in each one of these cases rather, I need to find out whether they are not divisible by 8. So I know that 154, if I see, is not divisible by 8, but I have to check whether this is divisible by 6. So I know that it ends in 4, which means it's divisible by 2. But when I add up the digits, when I have 5 plus 4 is 9 plus 1 is 10, 10 plus 7 is 17, 17 plus 8 is 25, 2 plus 5 is 7 does not go in the 3 times table. So which means that it is not divisible by 6. So don't just get carried away by saying that yes, this is definitely not divisible by 8 and it could be an option. So please check with each one of them and you will find out that you will have this particular number here which is D, is divisible by 6. So let's make a quick check. It's divisible by 2 because it ends in 2. When we say 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 7 is 17, 17 plus 1 is 18, 1 plus 8 is 9, 9 comes in the 3 times table, so it is divisible by 6. Let's look at 622. Is it divisible by 8? The last 3 digits we'll have to check for the divisibility by 8. So when I take 8, you will have this as 8 5s are 40, 8 6 are 48, 8 7s are 56. So we will have 7 here and a 56 written here. And when we subtract, this becomes again a 62. And now again, I'm not able to. So this definitely does not go in the 8 times table, but it is divisible by 6. So you will have D as one of your answers. You can make a quick check by dividing the entire number and making sure that you are right about it. You also have E, which again goes in the 6 times table, but does not go in the 8 times table. And the last one would be H, which is again divisible by 6. How do we do that? Because I know it ends in 4, it's divisible by 2. Let's look at the 3 times. 3 plus 6 is 9, 9 plus 6 is 15, 15 plus 5 is 20, 20 plus 4 is 24, 2 plus 4 is 6. 6 goes in the 3 times table, divisible by 2 and by 3, so it's divisible by 6 definitely. Let's look at divisibility by 8. So we have 654 divided by 8. And when I divide it, once again, as we did it here, we will have 8 sevens are. And you see that again, you will have the remainder, which is a sorry, 8 are, we need to make it, sorry, 64, I'm sorry. So we have this as 64 and this becomes 6 and 4, and when I subtract it is 1 and 4, which again is not. So it's not divisible by 8. So if you've had fun, download more worksheets and try them out.